when we were looking at the like sine and cos, and I put a k in there, and I said you'd have to do the chain rule and divide. Well, it could have been more than just k. It could have been a whole line, ax plus b. If you had the ax plus b inside, you'd have a chain rule, but the only thing you'd have to multiply when you do the chain rule is multiplied by 5. So if we quickly did these derivatives, nice review of derivatives, the 7 would come out in front. Subtract 1 from the exponent, keep the inside the same, and then you'd multiply by 5. So if you had any power rule with an ax plus b, the derivative would be, well, that here the 3 would come out in front, the inside stays the same, subtract 1 from the exponent, and the chain rule would say multiply by a. And this would be true of any derivative of any form. So we're just going to practice some of our derivatives. Practice in natural log, practice in e to the x, practice sine, practice cos. And I'll get you to do them first, and I'll put up the answers in a second. So that was just good for us to practice some of those regular derivatives. And each of them would have a chain rule, but the chain rule, if there's just a line, ax plus b is basically the graph of a line. So I'm going to say if there's just a line, just ax plus b inside of the function, then the chain rule is just a number. And if the chain rule is just a number, you can undo that multiplying when we work backwards by dividing. So now we can integrate anything that has an ax plus b in there by doing our regular rules for integration and just adding the fact that we're also going to have to divide by that a. We have to undo the chain rule as well as undoing all the other rules that are present. So here, I would have, right, I want to find the integral. I'm going to rewrite this as 5x minus 4 to the 1/3 dx. And since the inside is in the form ax plus b, that allows me to work backwards. First, I'm going to work backwards with, okay, I have a power. That means I add 1 to the exponent and divide. My chain rule, if I was checking this to see if I was right, if I would do the derivative of this, the derivative would also have a chain rule where you multiply by 5. So we're going to also have to divide by 5. And not forget the plus c. We have fractions inside of fractions, so I'm going to take this 20/3 and multiply by the reciprocal. final answer. You can try the next one. I'll put the answer up in a second. I rewrite that one with a -8, add 1 to my exponent, divide, and also have to divide by 9, so you'd have a -63 on the bottom. And so we could do this with natural log, e to the x, sine and cos as well. So, I'm going to get you to try each of those ones. Give you about 5 to 10 minutes to do that. If you get done early, you can look at any one of the exercises that was assigned for today. First one is a 1 over x graph. And one of the things that you can get good at these, as far as figuring out what kind of graph this is the ability to just ignore numbers. The ability to ignore the 15, the 3, and the 5 and say this is, on the top is just a constant, so I just think of 1. And on the bottom is just a line, which I just think of as x. And if I think of it as 1 over x, I recognize the natural log. So the 15 is just a constant. Natural log of, technically we should put this in absolute values. You can add the absolute values there. Absolute value of 3x minus 5. And then because you would have chain rule, we'll have to divide by 3 as well, plus c. Next one, an e to the x graph, so it would stay exactly the same, but there would have been a chain rule when you do the derivative where you'd have to multiply by a -3, so we divide by -3 plus c. Sine and cosine. Working from cos to sine would be negative, so working backwards, we'll have the negative. And, of course, chain rule causes us to divide by 6, plus c. And finally, sometimes feel like I need to write something on the other side of the equal sign, because we're doing something. If I just write equals, it's not equal to what I had before. Something's changed. So I just wrote, if I take the integral of f of x dx, I'm going to get, the sign is not going to change here, because the derivative of sine is just cos. We have the 9x minus 1 divided by 9 plus c.